Hi all, welcome to the session about the dark side of cloud configurations. Today we're going to talk about a cloud configuration and cloud security. But before, a little bit about myself. My name is Vladi Sandler, I'm 32 years plus one. I'm the co-founder and the CEO of Lightspin, a next generation cloud security platform. I have more than 30 years of experience in security, both red team and blue team. And in the last 6 years, I invested a lot of time on learning offensive side of cloud security, and that's exactly what we are going to talk about today. So let's try to understand the problem before we go drill down. So the problem is not a new one, it's the misconfigurations problem. But what is interesting about this problem is the approach. This specific problem has two different approaches. The first one is a Fortune 500 companies which actually continue to do an M&A process, like PayPal, for example, which is an on-premise company, but during the M&A process, they acquire a cloud-based company. Now, it's interesting because they don't always have an ability to do a good due diligence on the risk level of the cloud environment, which is going to be connected to the on-premise one. From the other side, we see companies which are part of the digital transformation process are actually migrate to cloud or create their products on the cloud from day one, like Hulu, Netflix, Monday.com, and more. Now pay attention. Once you move to single cloud like Amazon, only on Amazon we have more than 2,500 different IAM policies. So how should I handle a scale? What should I do when we are moving to Azure and Google Cloud also and become to be a multi-cloud environment? On some point, we even implement the Kubernetes and we become to be a multi-cloud service mesh. So our environments are distributed between the multi-cloud and the hybrid cloud. We always have a starvation for experts, and there is no holistic solution that can help us to manage this environment. And in the end of the day, everyone in the organization can do deployment. So we come to the situation of misconfiguration. The bigger problem is not the misconfigurations, it's the exploitation of them, something that we call configuration vulnerabilities. And that's what I want to show you today. But before, a fun fact. All the companies that were breached last year were compliant. Now, it's interesting because it means compliance is not good enough. So even if you are going to use an open source tool or some vendors are going to do benchmark analysis and compliance, you actually now can understand the checklist analysis to check if you're standing in regulation or not. It's not good enough. And even more, using that we can understand a couple of things. If in application layer we have data and we talk about application security, which brings us to application vulnerabilities like SQL injection, and if in infrastructure layer, we have the network, and we talk about network security, and we have network vulnerabilities like R poisoning, in cloud, everything done by infrastructure as a code. So we talk about configurations and configuration security, which bring us to new domain called configuration vulnerabilities. And in this case, we are going to exploit attacks like privilege escalation via EC2 instance, run instances permission, that we're going to present today. So before, let's try to understand which kind of security configuration issues do we have. Basically, there is three kinds of them. The first one is a misconfiguration, a human error in configurations maybe. The most famous one and classical one can be the example below. We have an EC2 instance which is exposed to the internet behind a load balancer. But by mistake, the DevOps exposed the same EC2 instance directly to the internet by providing a public IP. Now, that means that the attacker actually can communicate directly with this EC2 instance. Another great example for security configuration issue is a weak configurations. I mean, the best practice say use TLS 1.3, but we did a bad practice and we are using SSL version 3 or TLS version 1, which are vulnerable to poodle attack. The last kind is risky default settings. For example, we have a keeper which is in use by all of these EC2 instances that you see here, connected to them. Which means once you compromise one EC2 instance, you can compromise all of them. And it's actually a problem. I know that management of keepers it can be really difficult and complicated, but if the attacker can compromise all of your servers, it will be probably much more bigger problem. So probably we should do that. So configuration vulnerability, it's one of the type mentioned above, or a couple of them, that can be exploited by the attacker and applied in any attack tactic from privilege escalation, lateral movement, persistency, and more. So now I think it's a good time to see a use case. Let's talk today about a privilege escalation via EC2 run instances permission. If you're not familiar with run instances permission, it actually allowed us to launch a new machines on Amazon. So in our use case, we have a classical environment. In this environment, we have the EC2 instant Jambox server, which the DevOps actually used the internal employees in order to connect the environment and manage the VPC. As you can see, this specific VPC has more. It has RDS and another EC2 instance, which exposed to the internet on SSH, and it actually has two problematic issues. The first one, its keeper was exposed to a public GitHub. The second problem is that this specific server has three permissions: run instances, pass roles, and list roles. And that's exactly what the attacker is going to exploit. So, our attacker browsing to the public GitHub and obtain the exposed SSH keeper, using which he's going to connect actually the first EC2 instance. Since the attacker actually has a list role attached to the machine, the attacker can use it to discover which kind of roles we have in this environment, and that's how the attacker discovered the maintenance role, an administrative role. Using the run instances and pass role, the attacker can create a new EC2 instance and attach for that the maintenance role that discovered before. And since the attacker actually has SSH keeper that he discovered in the public GitHub, it can use it during the EC2 launching process and use it again to configure the machine with that. Which means now using a lateral movement, the attacker can access the new machine, which has an administrative role, and actually compromise the VPC. So now I think it can be a great moment and do some demo. So let's see how does it look. So great. Our attacker actually authenticated to our EC2 machine just because it had the SSH key. And from this moment, the attacker will start to do the due diligence and the discovery process. The first step, it will be go to the metadata API of the machine and get more information about the machine, including extract the dynamic key, the temporary token called STS. We have here the access key, the secret access key, and the token. Don't worry, I took care of it before, so we have it in our environment variables, so we don't need to waste time on that on this moment. In the next step, the attacker should understand which kind of the permission this specific machine has. So we can use classical open source solutions like Enumerate IAM, which is going to do a brute force attack and help us to answer this question. Once we execute the tool, it will start to do a permission brute force attack and will try to enumerate and expose all the attached roles to this specific machine. And as you can see here, this machine has several interesting permissions, but the most interesting is list roles, which means we can stop the enumeration attack and we can start use the role. Of course, the machine has more and we can continue a brute force or just trying by ourselves If, for example, we will run the following command, we can see, as we saw before, there is a get caller identity, so we can see that this machine use mgmt role. We can try to execute another command like s3 bucket ls and see that specifically there is no bucket permissions attached to this machine. But as I said before, we want to use the AWS IAM list roles. So once we execute this command, we can map all the existing roles in the environment, our Amazon environment. So next step will be to filter this information using JQ so we can map better visibility. And now we can see that there is a maintenance role that can be attached to EC2 instances. In the next step, we are going to use run instances command and launch a new machine in our environment. Sorry for that. A new machine in our environment, and the machine successfully created. I guess you want to know what exactly I did. So I browsed again to the metadata API and extract from them image ID, instance type, our subnet ID and group ID, and I know the maintain roles that I'm going to attach. About the key, I use the same key pair that I discovered on the public GitHub. So now the attacker will take the new private IP address which was created and going to do a lateral movement. Great. So we authenticated to the new machine, and once we run the get caller identity command, as you can see, we actually now using a maintenance role, which means we did a privilege escalation in the environment, and actually now we have an ability, which is an administrative role. So now we have an ability to take control and compromise the VPC, the whole VPC. So what actually we can learn from this use case? It's really great use case, because from this moment we can understand a couple of things. First, don't rely on your cloud providers. I mean, they don't really responsible for permission and configuration. It's something under your responsibility, which means you should take care that you did it correct. Compliance is not enough. We need real security. We need to do best practice cloud security in order to handle the problems. So in order to do that, my approach is view your cloud stack from an attacker's perspective. Once you do that, you can better understand how does the attacker see your environment and how that attacker going to exploit different misconfigurations or risky over permissive in order to cause damage to your environment, which allows better estimate the risk of the environment, better estimate the priority to take care of the different problems, and of course, better prepare a mitigation plan, both open source, vendors, or just best practices that we should do inside the environment. And of course, be proactive. Prevent the data breach at the configuration stage, which means both on the CI/CD pipeline, we can do a lot of analysis, static configuration analysis before if we use Terraform, for example, and both once the deployment happens. We can analyze the environment, we can find misconfigurations, and we can take care of them before something happens. Because if we will wait until something will happen and we will detect the attacker in real time, it's too late. The meaning is the attacker is in our environment and we don't really want to go there. So that's the most important point on our approach. Great. So if you have more questions, feel free to contact me and subscribe our LinkedIn page. And for anything else you want, feel free to contact me. Thank you for your time. It was nice to meet you.